Okay, so this is the first lesson of Chapter 3 on graphing exponential functions and simplifying exponents. So we're going to start by graphing our first example. Please make sure you read through the information that's above the example in your notes, and we will discuss it on Tuesday when I return. So we have our equation here of h of x equals negative 2 times 2 to the x minus 1 plus 3. This is our transform function. Our mother function is actually 2 to the x. So this value of 2 right here, that's our base. And so we're transforming from 2 to the x to negative 2 times 2 to the x minus 1 plus 3. So in our transform function, we still have our a, b, c, and d. So we still need to make sure that our x is still a 1x, so anything that's inside the parentheses with it has to be factored out, just like it was before with transformations in Chapter 1. And the a, the b, the c, and the d still do exactly the same things they did before, and we use them the same ways we did before. So in our function, and let me get rid of this mother function, I'll write it to the side. Okay, the mother function is f of x equals 2 to the x, like I said. Alright, so our a is going to be the negative 2. The b is going to be this number that's right inside here. This number right here. So that's just 1. So let me mark this. So this is actually a, b, c, and d. So c is going to be positive 1. Remember, anything inside the parentheses, you change the sign. And d is going to be equal to 3. Now once we have our a, b, c, and d, we now need to start finding our points. Now the difference between our equations now, or our graphs now, and our graphs in Unit 1 is I'm not going to give you your starting points. You need to find them. So we need to graph f of x. We need to find our starting points for f of x, our mother function. Now, because of the way students are, they tend to mess up with the exponents when they're negative. So I'm going to actually start with the positives and then go to the negatives. So I'm going to start with 3 and go down to 1, 0, negative 1, negative 2, and negative 3. Now remember, f of x is equal to 2 to the x. So y here is going to be 2 to the third power, which is 8. The next one is 2 squared, which is 4. 2 to the first for 2. 2 to the 0, which is 1. Now when we get to these negatives, all that happens is these original points that I have up here, they just flip over because that negative exponent is going to take the reciprocal. So 2 to the negative 1 is just 1/2. 2 to the negative 2 is 1/4. And 2 to the negative 3 is 1/8. So there's my original function, and I'm not going to graph it. I'm going to graph my transform function. So to graph my h of x, I'm going to do exactly the same thing I did with my transformations. I am going to divide by b, add c. I am going to multiply by a and add d. So let's start with our x values. Let's make that a little big. Let's make it a little small. We don't need as much. Okay. Take my original x values, and that's 3, 2, 1, 0, 1, or negative 1, negative 2, and negative 3. My b is 1, so I'm going to divide by 1 and add 1. Okay, so 3 divided by 1 plus 1 is 4. 2 divided by 1 plus 1 is 3. 1 divided by 1 plus 1 is 2. 0 divided by 1 plus 1 is 1. Negative 1 divided by 1 is negative 1, plus 1 is 0. Negative 2 divided by 1 plus 1 is negative 1. Negative 3 divided by 1 plus 1 is negative 2. So these are our new x values. Sorry about that. I was trying to get the highlighter to work. Okay. Now we do the same for our y values. And our y values were 8, 4, 2, 1, 1/2, 1/4, 1/8. So we're going to multiply by negative 2 and add 3. So 8 times negative 2 is negative 16, plus 3 is negative 13. 4 times negative 2 is negative 8, plus 3 is negative 5. 2 times negative 2 plus 3 is negative 1. 1 times negative 2 plus 3, oh, did I mess up? Is positive 1. There we go. Negative 2 times 1/2 is negative 1, plus 2 or plus 3 is 2. Negative 2 times 1/4 is negative 1/2, plus 3 is 2.5. 1/8 times negative 2 is negative 1/4, plus 3 is 2 3/4. So there's our new points for our y values. And that's what we're going to plot. So I'm going to come down here. Now the likelihood is, even though our, hold on here, where would we want to go? Look at my numbers. So probably want to, yeah. Okay. So even though we're going to go, our table says negative 13, I'm not going to count all the way down to negative 13. I'll be able to plot most of my points and I'll be good. So if I go to 3, negative 5, I'm right here. 2, negative 1, 1, 1, 0, 2, negative 1, 2.5, and negative 2, 2 3/4. Now if you look at the shape of this, this is an exponential, but it's upside down. And it's upside down because of that negative a that we had. It's reflected it over the x-axis, just like it did with our transformations. So this is what our graph looks like. Now, there is an asymptote here. The asymptote is located right here at negative 3. Because if you look, those numbers are getting really close to that negative 3. They're starting to get smaller. And that distance is getting closer and closer. So that's where our asymptote is. There's not a vertical asymptote here because those are just going to keep getting bigger. The other y values in the other direction are going to get bigger. Now, it's easy to figure out where your asymptote is going to be because it's going to be equivalent to your d value. So my d is going to tell me where my asymptote is. And a exponential has a horizontal asymptote. So let's write that down so we don't forget. Okay. So let's figure out our information. Oops, sorry about that. So I know my asymptote is at y equals 3. The domain of an exponential is all real numbers. The range is it's going from negative infinity up to 3. Now it's not going to hit the 3, so we keep that in a parentheses. And my y-intercept. If it wasn't on my graph, all I would have to do is put 0 in for x, just like you normally would do. But I can see that it's at 0, 2. Okay. That is the first example. We will be practicing this a few times throughout the unit. Let's move on to our next examples, which is on simplifying. So we're going to be using our properties of exponents. Make sure you review them. Just a quick reminder, I'm going to go all the way to the bottom here, that if you have like x to the third times x to the fifth, you add those together and you get x to the eighth. X to the third divided by x to the fifth, you subtract your exponents, so you get x to the negative 2. The problem is you cannot leave it as a negative exponent, and the negative means flip. So it becomes 1 over x squared. If you have an exponent to another exponent, that means you multiply. Okay, so just a very quick review. We'll keep reviewing those as we work through our examples. So let's start with example 1. So we have multiplication in our numerator with a exponent in a denominator. So the first thing I want to do is I'm going to simplify my numerator. And so I'm going to apply the first law, which is add the exponents together, and I get x to the third over x to the negative 3. Well, this negative here in the bottom tells me to flip it over. So if it's in the bottom, it's going to flip to the top. That's giving me x cubed times x cubed. So my final answer is x to the 6th. Okay, move on to the second one. Now if you notice, this one's a little different in the fact it's got a plus sign inside of it. So I can't add variables together if they have different exponents. So I can't do what I did in the first problem. I have to do something different. Now this denominator of x to the negative 5 is underneath both parts of my numerator. So what I'm going to do is I'm going to split it into 2 fractions. I'm going to write a little note, split into 2. So I get x to the 7th over x to the negative 5 plus x to the negative 1 over x to the negative 5. Now let's get rid of our negative exponents. If it's negative in the bottom, it moves up to the top. So that means I'm going to have x to the 7th times x to the 5th. Over here in the other one, that negative 1 is going to go to the bottom. The negative 5 is going to go to the top. So they basically change positions. So that's x to the 5th over x to the 1st. Now we just simplify. So in the first one, we're going to add our exponents together and get x to the 12th plus, in the second one, we subtract our exponents and we get x to the 4th. We need to make sure we keep going until we have all positive exponents. We do not leave them as negative exponents. Okay? Next one. This one seems to give students trouble, and it's actually not that hard because if you think about it, we actually have something on the outside of the parentheses that's being multiplied times everything in the inside. And if you remember, if you had something like this, you would distribute 3 to the 2x and 3 to the 1st. You do exactly the same thing with this one, this example. So I'm going to distribute x, y to the negative 2 times xy squared minus, and multiply it times the second one, xy to the negative 2 times 3y cubed. Add our exponents together. So I have x and x is x squared. Negative 2 plus 2 is 0, so I have y to the 0 minus, I only have one x and I have a 3, so that's going to make it just 3x. And the y's, I have negative 2 plus 3, and that's y. Now the last thing is the fact that we have this y to the 0. And the thing to remember is that anything to the 0 power is going to equal 1, as long as your base is not a 0 itself. So, like 2 to the 0 power is 1. X to the 0 power is 1. Negative 5 to the 0 power is 1. So that y to the 0 just changes to 1 times x squared, which is just x squared, minus 3xy. Okay. Let's go to number 4. Number 4 is going to take some space, so make sure you give yourself enough room. And what happens here is the fact that, notice we have a minus sign in the bottom. Because of that minus sign is in the bottom, just like if it was a plus sign, we cannot split this. Okay. Because the denominator would have to be underneath both parts of a numerator, but one numerator cannot be over two parts of a denominator. Okay? So we can't split it. So what we're going to do is we're going to simplify the numerator, and then we're going to simplify the denominator. Well, x to the negative 1 becomes 1 over x, divided by x minus 1 over x. Now the process to simplify this is pretty much the same as what we did when we do our inverse functions. We get everything to have a common denominator, or we multiply by a common denominator. Either one. Common denominator for our two fractions is x, so I'm going to multiply by x over x. Now just distribute. X times 1 over x is 1. X times x is x squared. X times 1 over x is 1. So we have now 1 over x squared minus 1. We have a positive exponent. Can't simplify it anymore. We could factor the denominator, but it's not going to help us because we don't have anything in the numerator to get rid of. So we just leave it alone. And that one's done. The key thing to remember is that if you have anything in your denominator, like a minus sign or a plus sign, it cannot be split into two fractions. Okay, this is the last one we're going to do today. The word problems that are at the end of this section, I will cover them when I come back. Alright? So, the thing to remember with this one is we have roots. Roots are rational exponents. So if I have, hold on a second, if I have the cube root of x, this is technically x to the first power. You rewrite it as the base of x with the power over the root. Okay? So what we're going to do is we're going to just simplify this. So this is 4 times x to the 1/3 times x. My power is 2, my root is 5, so it's 2 over 5 times, for the last one here, my power is 1. This is a square root, so there's actually an invisible 2 here. So it's x to the 1/2. Now we just add our fractions together because we're just multiplying same bases. So common denominator, because you need to be able to do this without a calculator. Common denominator between 2, 3, and 5 is 30. So I'm going to make everything over 30. So that makes that 10 over 30 times x. So this would be 12 over 30. And then this would be 15 over 30. We still have the 4 in front. It really doesn't do anything. It just keeps coming down. Now add your exponents. 10 over 30 plus 12 over 30 is 22 over 30. 15 over 30, it now becomes 37 over 30. And you're done. Okay, so these are the examples for the assignments you've got. If you have any questions, I'll be back on Tuesday. You can ask them then.